out there in cyberspace. My name is James Link with the Nashville ISA section. While I'm here, before I get started, I want to point out I'm the president of the local ISA chapter. We have here with us Bob Lindeman, our chapter secretary. Stan Spence, our program chair. He's with us tonight. Our treasurer, Mark Goldstein, he's online tonight. He's attending virtually through cyberspace. And our vice president, Darren Paintley, was supposed to be here tonight, but he's on sick, so he's not here with us. I have a very interesting topic tonight: arc flash common misconceptions. When I was brainstorming last month, I was trying to find a good topic. And then about the time that I was sitting there at lunch, and all of a sudden somebody brought a copy of Electrical Construction and Maintenance and laid it on my desk. And I saw the title of it, so the cover article. And I said, okay. Picked it up and read the article, recognized the article. And I said, you know, as a controls guy, most of us work in panels with variable frequency drives, servos. I know at Bridgestone we'd get machinery would come in from Japan, and it would have a panel with a PLC, the drives, the starters, and everything in there, and 480 volt three-phase coming into the panel. And so I think as controls engineers, we need to have an understanding of just what is an arc flash sticker is, what it means. And so as I read the article, you know, there's a lot of common misconceptions about arc flash. But anyway, our speaker tonight, so I thought it'd be a great topic. Our speaker tonight is Mr. Thomas Northcott. And the meeting has discussed common arc flash misconceptions that put electrical professionals at risk. Okay? The purpose of the meeting is to help provide knowledge about arc flash as well as protect yourself from the severity of the hazard. Employers of electrical workers must also gain an understanding of NFPA 70 and OSHA requirements. Our speaker, Mr. Thomas Northcott, he is the Senior Power Engineer and Branch Manager with Jacobs Technology in Tullahoma, Tennessee. Tommy has over 20 years of experience in the electrical engineer as an electrical engineer, project manager, arc flash program manager, electrical safety trainer, and utility manager. Tommy brings a broad range of experience with his passion towards electrical safety. Tommy is a certified reliability leader and certified in maintenance and reliability professional. He also has a clear vision of how maintenance and electrical equipment can have a direct impact on personal safety. Tommy has a Bachelor of Science in Electrical Engineering. He's a licensed professional engineer in 2 states. He's a principal committee member of the NFPA 70B, Committee for Recommended Practice of Electrical Equipment Maintenance. Tommy lives in Tullahoma. His wife of 20 years and 4 children. I've known Tommy myself personally for 12 years, and I know for several of the years I knew him when I was working at the base, you know, he was the arc flash czar, shall we say. That's the best way to put it. Explaining and making sure that the right stickers are on there. This is a very large place with a little bit of everything as far as electrical goes. So he's got a lot of practical experience, not just working, you know, doing calculations. So I turn it over to Tommy right now.
Well, thank you.
Thank you, gentlemen.
So, go through the introduction slides. I think that was plenty, but I'll just let you know about this presentation. It's really a culmination of several years of having the opportunity to go to different facilities, different companies, and aid them in various ways with their electrical safety and their arc flash programs. And as I did this, different approaches that I used, I found that I ran into the common themes in a lot of places that I went. So this is kind of a collection of these common themes, common misconceptions that I've seen across the industry. Most of them are still pretty prevalent. Some of them have gotten better over the years. But this is, my goal is to educate folks and to help folks in your day-to-day work. So if there's a question with anything I'm talking about, it's a casual presentation, feel free to interrupt me, ask a question, we can talk through it. But otherwise, we'll stand up here and listen to myself just make sure we're on the same page, arc flash is essentially when you have an electrical fault that travels through air. It creates plasma like a lightning bolt. It can reach 35,000 degrees Fahrenheit, and in comparison, the surface of the sun is about 9,000 degrees Fahrenheit. At those temperatures, things evaporate, rapid expansion, rapid heating, and just creates a very dangerous situation. And unlike shock, where you have to be close enough to either contact it or for higher voltages where it can jump out towards you, with arc flash you can actually be burned as far as 10 feet from the source of the fault due to the arc blast. And one common misconception is that arc flashes happen at high voltages. And being a power guy, the definition of high or low voltage stops at 600 volts. So 480 volts is still low voltage. I know a lot of folks out there consider 480 to be high voltage, but arc flashes we'll talk about later on is really voltage independent. It doesn't really matter. And actually 480 volts is one of the most dangerous classes of voltage when it comes to arc flash severity. Then you also have the arc blast. When you're talking about the temperatures, the rapid expansion of air, most of your arc flash in industry is going to happen inside an enclosure, and all of that rapid expansion wants to get out somewhere, and it forces its way typically right towards the worker out of the front of the enclosure in a pressure wave that is commonly called the arc blast. And it can blow doors off of enclosures. If you've ever been in the room with an arc flash event, it's extremely loud. I'm also a formerly enlisted Marine, and so I got to play with a lot of really cool weapons, and arc blast volumes that I've experienced, it puts to test any of the weapons that I've got to fire. They're very loud, large, a lot of energy, all in an instant. That's the thing about electrical hazard. I'm admittedly biased to it, but with electrical hazards, I mean, an instant it's over. There's no bobbing and weaving, there's no getting out of the way. Once it happens, it's too late. So we have to think about the hazard ahead of time and protect ourselves going in, rather than trying to adjust through once it starts to happen. So again, these are a collection of myths, if you will, or scenarios in a lot of cases that I've ran into as I go evaluate facilities and trying to clarify the truth behind the scenario and what the approach should be. So one of the scenarios is I don't work with high voltage, so I don't have to worry about arc flash. I hear that all the time. Go in somewhere and being a controls based audience, that a lot of times with control systems, I get that. Well, all I do is work with PLCs or anything over 48 volts or 24 volts, and I don't mess with it, so I don't have to worry about arc flash. Well, there's a simplified equation when it comes to arc flash, and that's essentially your available fault current times the amount of time it takes to clear that fault. And the arc flash energy levels are voltage independence. It has more to do with the fault current and the clearing time. And in fact, over half of all the arc flashes occur at 480 volts. And out of all the analysis that I've done and evaluations that I've seen, the vast majority of the really high energy levels are at 480 volts. And unless it's a brand new system to where it's been designed to completely isolate the control systems from the voltage source, oftentimes your control systems are right there in the cabinet with 480 volts present in that enclosure as well. Typically, high voltage substations, people will think I was crazy when I worked out the base. We've got 960 to 1,000 volt substations. And from an arc flash standpoint, to me, that's the safest place in the base, is to be underneath those buses in the middle of that substation, because there's so much protection on that equipment and on those systems, and they're evaluating so many minute details about that electrical system that the likelihood of there actually being an arc flash in the substation is extremely rare. Where when you get to the 480 volt systems, you're happy if you've got a thermal over voltage or overcurrent protective device. So that's one of the reasons why because clearing time, again at the top there, the clearing time is one of the factors in your arc flash energy. So the more sophisticated your protection is, the quicker the clearing time is, and your arc flash energy reduces. So it's not voltage dependent. Another one, kind of alluded to this, I'm a controls technician, anything over 48 volts, and I get an electrician to work on it. And that's a great philosophy. One of the things, that I develop and also teach electrical safety, and one of the key things that I focus in on is every electrical worker is task qualified. There's nobody that knows every single aspect about electrical safety. And so one of the most important things as electrical workers is for us to recognize and admit to ourselves our limitations with electrical equipment. So knowing not to mess with anything over 48 volts is a good start. And what the 70E says is that circuit parts that operate less than 50 volts AC or DC shall not be required to be de-energized. That's the low enough threshold to where you're not going to have enough current flowing through your body that it's going to kill you or cause you problems. However, the key is make sure you're not exposed to the higher voltages. And that's a lot of cases where I walk in when I do an evaluation of a company and their electrical safety program. I'll spend the first day or two interviewing a lot of their employees and just walking around with them, finding out what their day-to-day tasks are and figure out where some of the gaps are in their safety. And oftentimes the instrument technicians, for example, I'll talk to them and they're like, yeah, I don't mess with any of that stuff. I just, I stick with my controls systems. I stick with my low voltage, nothing more than 48 volts. I'm like, okay, well, can I follow you around? And follow them around and say, yeah, this is one of these that we have problems with all the time. Probably 3 times a week I'm in this enclosure. He opens the door and he shows me the low voltage system that he's always working on. And I'm like, you realize that's a 480 volt PT that's in the corner there? And these are 480 volt terminal strips, and not realizing the blinders are on, that this is what I'm working on, and it's not a hazard. And that's true, but when you open that enclosure, you're exposing yourself to a potential arc flash hazard because of that exposed 480. So changing the mindset of not just what am I working on, but what am I exposing myself to? And that's the thing that we've got to protect ourselves, not what we're working on, but what we're exposed to, the hazards that we're exposed to. If the enclosure door is closed, I don't need arc flash PPE. I used to get this all the time, but it's gotten a lot less common now that people believe that any old type of equipment, if you close the door, then you're safe, that the arc flashes can be contained. And the only time you can be sure of that is if it is arc rated, if it's designed to contain the gear, which would be a newer piece of equipment. And for the older gear that you have to unbolt or unlatch, we all know that when an electrician finishes their task, they bolt everything up, all the bolts, all the latches, before they walk off. Now they do the very least that they have to do, because they know they're going to be back here in another week. We don't want to have to undo all this again, so you just barely put enough latch on it to keep it closed under good circumstances, much less an arc flash event. And I like to show this picture because if you're familiar with this era of equipment, these metal or steel panels, when you unbolt them, they are a bear. I mean, it's huge, thick steel. And this, granted, this had to have been a long duration, bad protection situation, but the arc actually burned all the way through a hole right through the side of that. So that was significant arcing to come through there. But the reality is, you can look on the front here, and most of your electrical gear, unless it's arc rated, is going to have some ventilation. And so at the very least, you're going to have all that rapid expansion wants to escape somewhere. Where is it coming out? It's coming out the vents, which are typically right in the front, right where somebody would be standing. And if the vents aren't enough to vent it out, then it's going to rip the bolts off, rip the latches off, and blow the doors open. I've got a shelf of souvenirs of different bolts and latches and different things that I've collected in investigations of parts that blown significant distance. In one medium voltage outdoor gear, it blew the panel off about 25 feet, and we're picking up strip bolts like 50 to 75 feet back behind it. And, so it's a lot of energy trying to escape instantly. You can't count on the doors being closed to protect you unless it's arc-rated gear. But the thing to keep in mind with arc-rated gear is it's only, at least all the styles that I've seen to date, it's only arc-rated for normal operations. Once you open it up to do maintenance or do anything to it, opening those doors defeats that arc-rated characteristic. You got to treat it just like normal switch gear. So this just having doors closed is not the case. We gotta wear proper arc flash PPE. Another one is we only perform operations and contract out our maintenance, so we don't need arc flash PPE. That was a easy button that some of the smaller companies would go with. We don't want to have to worry about all this extra arc flash requirements, so we'll just contract out all of our maintenance and repair work, and then we don't have to worry about the arc flash PPE. So then the question is, when does the arc flash exist? Well, NFPA 70E gives us this definition, and I'll spare you that. You can read it if you want, but I'll boil it down to two scenarios. One, the obvious one, is when energized electric conductors are exposed, you have a potential arc flash hazard. If your conductors are out there where you can make contact with them, obviously that's a hazard. The other is when you're starting, stopping current flow. If you're operating a breaker, pushing a open close button, operating a disconnect switch, anything that starts or stops current flow, then on a three-phase system has a potential to have an arc flash hazard. You need to do an evaluation to assess that risk. Some of the common causes that we see with arc flash is opening or closing doors or removing a cover. We've even seen scenarios where, like right now, as the temperatures start to change, rodents and things like to find warm places to nest, and they'll get in electrical gear, and they like to try to get to the copper, but two, they like to strip off the insulation and build their nests, and they'll have it set up to where it's just perfect. There's no issue. They know where to walk. I don't know if it's a sixth sense or something, but then you open the door and you startle them and they jump, and then the gear blows up right in front of you because they got startled. I responded to a failure that was outdoor, air insulated medium voltage switch, to where you could see the charring on the concrete floor of the switch, where there's an arc flash vent inside the switch, and you see this little outline of a mouse in the corner over here, and then the remains of the snake that was following it. The mouse was able to jump, and when the snake got up there and crossed phase to phase, it initiated the arc. The snake blew the gear up. So you never know what's going to be going on inside there when you open and close the cover. Operating switches or circuit breakers, multiple things can happen there. You could be closing in on a fault, not realizing it, or anytime there's mechanical movement, there's an opportunity for failure of a part that could break and short phase to phase, break down that medium. So operating equipment can cause the arc flash. Racking a circuit breaker, to me, is one of the most risky things you can do on a distribution system, is rack a breaker on or off an energized bus. Then using tools or test equipment could inadvertently cause a fault. That's one of the common misconceptions that I don't have in this presentation, but that I get with the digital multimeters, that those test leads are insulated for our protection. Well, those test leads are not insulated to protect us from the shock. That insulation is there to protect us from inadvertently contacting another conductor, going phase to phase or phase to ground. We still have to use the voltage rated gloves when we use a digital multimeter for anything above 50 volts. And I get that argument a lot, and I do know that all good electrical workers will take their digital multimeter when they're done with it and disconnect their leads and fold them nicely, put them back in the original container, and put their meter in the container and close the box and set it on a shelf, right? Or do we wrap them around the multimeter and toss it in a bag, tool bag, or toss it in the back of the truck? And then we know that when we send our meter, if we get it calibrated, we send it off to be calibrated. You never send the leads with it, because then you got a 50-50 chance they're going to come back with it. And so you're not getting your leads tested like you do your voltage rated gloves. So how much do you want to risk your life on how many times that takes to put a nick in it that's going to come through and shock you through that? Those voltage rated tools and voltage rated test leads are not so you can hold those barehanded. It's to keep you from inadvertently shorting phase to phase or phase to ground when you're working around energized components. So the next one, as long as I have some arc flash PPE on, then I'll be okay. And this becomes more common in facilities where you have to travel distance. I see a lot with utility companies where the utility worker leaves the shop, has to drive somewhere and gets there and realizes, I've got my category 2 PPE, but what I need here is category 4. I don't wanna have to drive 15 minutes all the way back to the shop just to get my category 4 suit. I'll just wear my category 2, it's better than nothing, right? Well, that's not true. Your outer layer has to be rated greater than the arc flash energy level. And there's two ways that they rate them, either the arc thermal performance value or protection value. I see both of those terms, the ATPV, or the energy break open threshold. And this is how they test garments. The arc thermal performance value is the material. They take a cloth, whatever they're gonna make the garment out of, and they'll expose it to different levels of an arc flash energies. And at the point that it starts to burn or melt or show signs of degradation, that's the maximum level that it can be exposed to. So it's when it starts to burn or break down the material, that's the performance value. The energy break open threshold is when they take the actual garment that's been made and now they put it on a mannequin or put it on something where you button up all the buttons or Velcro, whatever it is, and start exposing it to an arc flash event. And at the moment that a button breaks open or the seam breaks open or something in that garment fails, that's the energy break open threshold. And so they take the lower of these two values, whichever is lower, and that's what they rate that garment for. And so whatever that rating is, if it's 12 calories, you don't want to expose it to over 12 calories, which most of our level 2 8 calorie maximum PPE is. Like this right here is a 12 calorie suit for a category 2 arc flash. If that was to be worn for a 30 calorie arc flash, the Velcro that's in the front may break open, expose whatever's underneath it, which typically is going to be a cotton t-shirt because that's what I prefer to wear under my arc flash PPE. And then that cotton's going to ignite, and the arc flash PPE is self-extinguishing. You can actually take a Bic lighter to a lot of it and hold it there long enough that it'll catch fire, and then you can just work your way through burning holes through it. So if you got a cotton shirt underneath your arc flash PPE and it breaks open and it ignites, then it's no different than just not having your arc flash PPE on anyway. So you want to make sure your outer layer is rated for the energy level that you can be potentially exposed to, or it could be a fatal decision. The next one is that we can just keep using the arc flash PPE tables and our employees will be safe. And if you're familiar with the 70E, the first option is to do the arc flash analysis, where you actually have a calculated calories per centimeter squared instant energy rating. In lieu of doing that calculation, if it hasn't been done, they've got these tables that you can reference that'll give you some guidance on what PPE to use. And the first table is the 130.5C, and that's the likelihood of occurrence. And that is where the table lists different tasks that you're going to perform. I'm going to operate a breaker, or I'm going to open a hinged cover. I'm going to rack a breaker off the energized bus. There's a whole lot of different tasks, and then it gives you whether there's a likelihood of arc flash to occur or not given that task. And if the answer is no, then you can fill that out in your risk assessment that the table says there's not a likelihood, then you make a decision whether you want to choose arc flash PPE or not. Most people see the no and just say, I don't need arc flash PPE. And that's a debate with the committee quite a bit of, well, that's not what we intended, and that's how it reads. You say no. If it says yes, there is a likelihood, then you go to the next table, which is the categories. This one is for specifically for AC systems. There's another table, B, little letter B, for the DC systems. But this gives you categories of equipment: 480 volt panel, medium voltage switchgear. There's several different scenarios. And based on that type of equipment and some parameters, it gives you an arc flash PPE level. And this is an example of the parameter for one of the scenarios. This is an 18-inch working distance. I believe this would be a panel, maybe an MCC. But here we have a maximum of 65,000 amp short circuit current available and 20 cycles of fault clearing time. And then your working distance of 18 inches is taken out of the IEEE standard for calculating arc flash distance or energy levels. But what you need to know is, based on the equipment you're working on, is it rated for a maximum of 65,000 amp short circuit current? Well, the challenge is this is really for somebody that's out in the field and there's no sticker on the equipment. How do I make a decision? In the field, most of the time, you're not going to know what the rating is for the equipment. The more challenging thing is the clearing time. The clearing time is not even the equipment you're working on, that's the equipment upstream, the upstream protective device. And how do you know the clearing time from that? Well, to do the arc flash analysis, I'm looking up make and model of a breaker or a fuse, whatever it is, and getting the time current characteristics curve and doing an evaluation based on the manufacturer's curve. And so you're not going to know the short circuit current of the device you're operating or maintaining out in the field. You're not going to know the clearing time of the upstream protected device. So I would argue that I have yet to find any scenario in the field that these tables are being used the way the 70E intends them to use. And the reality is, if you've collected this information to know this, you've already gone significant steps towards doing the analysis and doing a proper calculation, which I believe is the intent of what they wanted to do, was start steering industry to collecting that information to do the analysis. But most of the time, the tables don't get used appropriately, in my opinion. For those, if you're not familiar, this is a time current curve. You've got your time in seconds, your current here, so instantaneous high current is going to cause it to trip quickly. So if you have this, you can tell how quickly it's going to respond on a breaker. And some of the newer equipment is nice, like some of the 480 volt breakers have the settings that are set up in these different scenarios. So if you know what you're looking at, there are some newer equipment where you could maybe collect this information out in the field to make an educated decision on what PPE to use. But I don't have them in here. In some of my more detailed training, I've got real world scenarios where you've got the breakers in the field, and in some cases the tables were right and you would have been protected, and there's some cases where the tables would have been wrong and you wouldn't have been protected. So my approach, because I really like myself more than I think anybody else in the world, so if it's not stickered and the analysis hasn't been done, I'm going to be in a 40 cal suit protecting myself. Well, first I'm going to try to do it where I don't have to have the suit on, figure out a workaround. If I absolutely have to put a suit on, then I'm always going to wear the 40 cal and be dressed out as much as I possibly can so that I have the highest probability of going back home. I'd rather sweat for a little while than risk waking up in a burn center, because that would be really bad. So there's two choices for determining what the required PPE that you need. The first is arc flash analysis. And that's where you do the short circuit study, coordination studies completed. You've got the incident energy analysis, and the sticker's been posted on the equipment. That's the easiest. I've had scenarios where we've done the analysis on the equipment, and then not too long after that, downstream of some Schweitzer relays that gather all the information that a nerdy power engineer would really love to see, with the vectors and everything that you'd ever want to dig into was upstream. We had an arc flash event, and you're able to go download the event summary from the Schweitzer relay, and that reassured me that the teams that put together these IEEE standards to do the equations for the analysis are smart individuals, and the calculations are good. I am confident in putting my life in the PPE that's been selected by the arc flash analysis method. The other method is to use the NFPA 70E tables, which we just talked about in probably more detail than you wanted to. But you cannot combine the two on the same equipment, because there's oftentimes where, like operating a breaker, when the table says under normal operating conditions to operate a breaker is not an arc flash not a likelihood that there's gonna be an arc flash event, so most people interpret that as when I operate a breaker, I don't need arc flash PPE. But then you go do the analysis on your 480 volt equipment and realize, well, that's a 15 calorie energy coming into that. So now we've got to wear either level 3 or level 4 PPE to protect ourselves. Well, let's just say for operations, we're going to go by the tables because it says we don't need PPE. But if we take the cover off of it and expose energized conductors, then we're going to go by the calculation and wear the full suit to protect ourselves from that aspect of it. We can't do that. Once you do the analysis, you've got to go by the analysis regardless of the task that you're doing. So that's what it means by you can't combine the two in the same equipment. Now, the same facility you can, because it takes time to do the analysis. So you could have a panel on the wall that's on a circuit that's been through the analysis, it's been stickered, you know what the energy level is. You got another panel over here that's fed from a different source that hasn't had the analysis done on it. You can do the tables for that one, and you can do the sticker for the other one, but you can't mix the two with the same equipment. Once you run the analysis, that's what the hazard is, and that's what you protect yourself from. The next one is if a panel is rated in less than 1.2 calories per centimeter squared, then everything else downstream is also less than 1.2 calories per centimeter squared. Now, that was one that even I was guilty of in a lot of scenarios, assuming for a while until I started thinking it through and playing around with some of the arc flash software and realized that it's not necessarily true. It goes back to this equation of available fault current times the clearing time is what determines our arc flash energy level. And the 70 does have a requirement that employers must assess any equipment 50 volts or more for shock and arc flash hazards to begin with, so we need to analyze it. One easy one that I realized from the beginning, didn't have a problem with this. Anytime you run into a transformer, downstream of the transformer, now everything's changed and you've got to redo the analysis. There's a lot of scenarios for a medium voltage unit substation, for example, where you've got a medium voltage fused switch on the primary that could be 0.8 calories per centimeter squared, and then the immediate downstream main 480 volt breaker may even be over 40 calories depending on the size of the transformer, or certainly more than 1.2 calories per centimeter squared. So transformers impact the fault current. But also impedance reduces fault current. This is one that I overlooked for a long time, that you could have a scenario where a overcurrent protected device is right on the edge of the instantaneous trip setting. And if you were to add a very long conductor that adds just enough impedance to where now it's not going to hit that instantaneous current level, then it changes your clearing time, because now instead of instantaneous trip, it moves it into a delayed trip of whatever, depending on the overcurrent protected device. So there could be scenarios, while it's not necessarily all that likely, that adding some impedance into the system can go from a lower arc flash rating downstream to a slightly higher because of the trip settings. So we can't just assume that if it's 100 or 1.2 calories, that the rest of the system's safe downstream of it. The other issue that is very true in the real world is if you take consideration this of the variable fault current and the clearing time, and you look at maintenance and realize that in a lot of cases there's a lot of facilities that don't do corrective maintenance or preventive maintenance or predictive maintenance on their low voltage equipment, 480 volt equipment, well then that's going to often increase your clearing time. And if it increases your clearing time, it's always going to increase your arc flash energy. So it is important to maintain your equipment, particularly any of the 480 volt protective devices that have mechanical movements. You know, if they get gummed up, or if you have breakers that the contacts weld closed and they're not going to break or trip. There's all kinds of things that can impact your clearing time due to improper maintenance. And so maintaining our equipment is very important to the safety and the arc flash protection of employees. next one is we don't employ electricians. We sub out all of our electrical work. So therefore the NFPA 70E doesn't even apply to us. And this is, seen this in some of the factories that I've been to where essentially their equipment's on all the time from a distribution standpoint, and they're just hitting start-stop buttons to run lines, and they feel like, well, we're not really doing any electrical work, so we don't have to worry about this 70E. Well, there's some simple things that you can point out for the 70E that are required for contractors or for employers. Whenever they have a contractor, they've got to communicate what the known hazards are, information that's going to assist them in their assessments, their risk assessments, and also as the owner of the equipment, you're still responsible to provide the arc flash assessment to be able to determine what PPE the contractor is going to need, and then report any employee violations to the contract employer. And then as a contractor, you also have to communicate. You got to communicate to your employees what the host identified as hazards. Also make sure that all your employees are in compliance with the 70E, and then advise the employer of any unique hazards related to the work that you're performing, any additional hazards that they find, and if there was an issue with any of your employees, what action was taken to address it. And the next, and this happens a lot, the ARC or analysis is complete, the warning labels are applied, the employees have been trained, we've given them PPE, so now we're fully compliant, we're good to go. Basically, we've checked all our boxes and we're done, so we can move on. Well, that's not quite the case. What I like to call electrical safety culture is a never-ending journey. And one, there's audits that are required that at the very least you're going to have to go through. But the 70E gives the requirements for electrical safety program. I'm not going to read them all here, but all of these have to be in place for a company to have a compliant 70E safety program. Part of that is recurring, it has to be documented, is audits. There are 3 primary audits that are required. The first one is your electrical safety program audit. The objective there is to verify that the principles and procedures are compliant with the most up-to-date NFPA 70E, which is why they require the program audit to be on a 3-year cycle, because the 70E gets revised on a 3-year cycle. So the intention is the new revision of the 70E comes out, somebody takes that, does an assessment on your program, make sure that you pick up any of the new things, and everything's still compliant. And then field work audits, that's to verify the procedures are being followed. It's not just we've got everything documented, but it's more than just putting a check in the box. Are the employees actually following the expectations of the 70E? And all the audits shall be documented. The field work has to be annually audited. And then the third one is your lockout tag out program and procedure. This is to verify that it's being followed and is compliant with the 70E, and is required to be audited annually and documented as well. And the next one is that energy less than 1.2 calories per centimeter squared is not hazardous. And so to talk about that, what exactly is a calorie that we're talking about here? The calorie is the amount of energy required to raise the temperature of 1 gram of water 1 Celsius degree. And that's if you take your hand and put it in the hottest part of a big lighter flame for about 1 second, you just received about a 1.2 calorie per centimeter burn. And that's prior to the onset of a 2nd degree burn. It's a exposure that doesn't require treatment, and that kind of falls in line with what OSHA determines as a hazard, is something that requires some kind of treatment. However, you can imagine some of these synthetic materials, if you were to take a big lighter and hold it to somebody's clothing for a second, it could very well combust. And that's where, even though something's below 1.2 calories per centimeter squared, you can stand there with nothing on and it's not going to burn your skin. However, there's a chance if it's exposed and that the blast or the flame or something gets onto a flammable clothing, then it can still ignite, it can still burn. And that's the the reality of arc flash injuries is the severity of the injuries typically isn't because of the arc flash. It's because the arc flash ignites the clothing that the person's wearing, and then the clothing just burns right off of them. And it's one of those scenarios, if you've seen it's one thing my wife tells me is I've got an unhealthy fascination with electrical power and arc flash phenomenon, and so I've got all kinds of videos of tests that have been done, and the wrong clothing in arc flash event is not a stop, drop, and roll like we were taught in school. There's no putting it out. It happens, you're engulfed in the flame for a fraction of a second, and being engulfed ignites every bit of the clothing all at once, and it's just, by the time it happens, it's too late. One of the sobering learning points that I had as I investigated an arc flash event, this was a very, very impactful scenario for me, because I was on site. I had been toured through the medium and high voltage substations at this location by two particular high voltage electricians. They were excited about what was going on and what I was going to teach them, and they knew that things weren't really being done right, and I could tell that they really cared about what they did and wanted to do things right. The next day they sat through my 8-hour electrical safety training for low voltage and arc flash, and so they received everything they needed to know to protect themselves from arc flash. The next day I was teaching the same class to another group of their co-workers, and right around lunchtime the lights flashed, and I saw the other high voltage guys grab the radio, and I've got a background in electrical utility, and so I've learned over the years to recognize the difference between different flashes of lights, and it was obvious something had happened on their system. So I was like, let's break for lunch. It's pretty close to lunch anyway, figure out what's going on, and then we can reconvene after lunch. Well, turns out there was an arc flash event on the site, and it was the two guys that had toured me around 2 days prior, and had just sat through the whole day with me the prior day. And one thing I learned that I'd never thought about until this event was, anytime now that I'm in an equipment room and I'm putting on my arc flash gear, I take a flashlight and I turn it on and I put it on the floor close to the gear next to me, because I didn't connect the dots until after this, that equipment rooms are not, they're not normally occupied spaces, and so most of the time they don't have emergency lighting, and most of the time they don't have windows, and most of the time you have an arc flash event, that's the incoming power, and all the power goes out. And so in this scenario, I saw the trail, and you can imagine what the trail was, of these guys trying to find their way to the door to get out to the hallway so that somebody could call for help for them. And it was not a quick scenario, so it added time to response time for these guys to start receiving treatment. And it was because they weren't wearing their proper gear. They had it with them in a bag, in the room, off to the side, and their cotton t-shirts ignited. And there's nothing, once that happens, you can't put it out until it's pretty much run its course. So it's a very serious situation. So anytime you're inside this arc flash protection boundary of an arc flash hazard, you must be wearing the level of arc flash PPE that's calculated at the working area, working distance. And what we do is we calculate the arc flash energy decays almost exponentially, and so we can, if we know the magnitude of the incident energy at the point of the fault, then we can calculate how far it has to go back until it's at that 1.2 calories per centimeter squared. And that's the arc flash protection boundary. So if you're standing with your toes right here on this line and wearing nothing but your skivvies, we'll say, and it has the ultimate highest possible arc flash you could have, then you're going to be protected and you're not going to get burnt. However, if your toes are on that line and you're wearing one of these poly cotton jumpsuits or something, then there's a chance that it could still ignite that suit. So that minimum boundary distance is a safe distance, but just keep in mind what that really means. 2-3 inches back behind that would even probably help out. So I have PPE, so let's just get it done. And that seems to be the common theme too, of I've got my arc flash PPE, so let's just throw the arc flash PPE on and I'm gonna be protected and I'm gonna start operating breakers. Well, that's not the intent. The intent is to follow the hierarchy of risk control methods to where your most effective approach is to eliminate the hazard. Can you do it with the system de-energized? Is there a upstream device that can be operated remotely that can kill the energy to where you don't ever have to put on arc flash PPE? And then substitution engineering controls, these are all down to the effectiveness to where your last line of defense is PPE. So just because there's PPE available doesn't mean we go throw our stuff on and go do the work. We always want to go through this analysis to figure out, is there another way to do it to where we stay outside the hazard, we're not exposed to the hazard to where we don't have to have the PPE on. Because the reality is PPE is our last option. We would prefer to reduce the arc flash hazard by de-energizing the equipment, but keep in mind, de-energizing the equipment, you're starting, stopping current flow, so that could also have an arc flash hazard. So you need to evaluate that as well. You can modify equipment to reduce arc potential, modify protection. That could be, that available fault current or the amount of time it takes to clear the fault. If you can make an adjustment to the instantaneous to where it's going to trip a lot faster, that reduces your arc flash energy level to where you can make it safer. Replace equipment with safer designs. The point here is your PPE is the last option. You always want to have it available in case you need it, in case you have to be exposed to the hazard, but it's the last option. We want to work through the hierarchy of risk control methods first. In closing, some foundational principles. De-energizing is always the first choice, and really, de-energizing is a bad term. It's really electrically safe work condition, which is an FPA 70E's requirement that has several different steps to get to that, not just de-energized, it's locked out, tagged out. You verify that it's visually verified that it's open. You can do a live dead live method to make sure that it's de-energized. You go through all these steps, ground it if it's feasible to ground it, then it's safe to work on. PPE is always the last choice. Electrical safety is personal, make it a personal commitment. That's one thing when I started doing these electrical safety training courses, when I do the full course, I'll go around the room at the beginning and ask folks what they want to get out of the training. And when I first started doing this 10, 15 years ago, however long it's been now, I would get a lot of comments that I want to know what to do to not get fired. I want to know what the rules are so I don't get in trouble. And I mean, that was a common theme. And now, thankfully, the culture's changed to where most of the time it's more of a positive. I wanted to know how to not get injured, how do I make sure I go home at the end of the day. Because if it's not personal, if it's just because our supervisor, I don't want to get fired by my supervisor seeing me doing something wrong, the second you know he's not around, then you're going to take the shortcut or do whatever it is that you're not going to get caught doing. So it needs to be personal to really protect yourselves even when nobody's looking. I always look for possibilities to eliminate the hazard. Distance from the hazard is our friend, and so anytime you can use barricades or use remote operations, remote racking, any kind of remote distance is good. Testing is touching. That goes back to alluded to the voltage rated gloves. If you're going to be using digital multimeter over 50 volts, you should be wearing your voltage rated gloves because those test leads aren't insulated for your protection. Then ask yourself, what is the true condition inside that enclosure? Don't rely on assumptions. And also be aware of what you're exposed to, not just what you're working on, because oftentimes there's multiple voltage classes in enclosures, and you may be working on something that's controls level voltage, but it also may have some supply power inside that enclosure that's causes you to be inside that arc flash boundary. And then know that we are all only task qualified, and I kind of talked about that earlier. Don't be afraid to speak up if something seems unfamiliar. One of the learning moments for me as a young engineer was going around and collecting the information for the arc flash analysis, and there's some 480 volt MCCs at a particular wind tunnel test facility, and I didn't know a whole lot about them. In most scenarios, I'd walk up and I'd open the door and I'd get the nameplate data off of them, the settings, and so I was gonna do the same thing for this gear that I'd never worked with, and happened to be a test running, and I open one of the doors and I hear the breaker open, and all kinds of people come running out. What's going on? What happened? Why did this trip off? I didn't pay attention, but there's a sign on there that says opening this door trips the breaker, and it happened to be a very important system. I don't know if it was a lube oil system or some system that was critical to the operation of the tunnel, which tripped a bunch of other things and brought the whole thing down. I learned a very valuable lesson of I don't need to be just going out to equipment that I was only task qualified, and I was not qualified to do that task, but I thought I was going to go out there and do it. So keep that in mind. Don't be afraid to ask questions if you haven't been exposed to something, because again, it goes back to the electrical hazard is instantaneous, and the next thing you know, it's too late. You're burned or shocked or electrocuted. So we've got to be thinking ahead of time before we get into those. With that brings me to the end of my prepared slides. Happy to take any questions.
Question. Let's say you walk up to an operator control panel, and it's like what we described. You know, it's got drives, PLC, and a flat panel touchscreen, and there's some push buttons. And it's a large Hoffman enclosure, and it's closed up. And it's got an arc flash hazard level 2. So, is it safe to walk up and push that start button to close the contactor to run them over?
Where's the contactor that's closing?
It's inside the enclosure. So it's inside that particular enclosure.
Then the answer would be no.
No.
You need the level 2 PPE on.
I see.
Now, if it's a remote HMI operating station and the contactor is on the other side of the room and you're outside the boundary,
Right.
then you can.
Okay.
But if it's inside that enclosure and 480 volt contacts are making and breaking contact inside that enclosure, then you've got to wear the arc flash PPE.
See.
And we've actually had scenarios where the specification called for remote operations and racking box, and the contractor designed it to be sitting on the side of the gear. So yeah, for the 3 or 4 on the opposite end, you're outside the boundary of those, that's great, but now all these ones that here, it really bought you nothing. So you need to make sure all those remote controls are outside the boundary of the equipment that's gonna be actually operating.
What about something that's kind of a combination motor starter? It's got push buttons and stuff on it. You know, is that same way, even though it may be rated, you know, this enclosure with this breaker and motor starter in there with push buttons on the side to start and stop a motor. And that's like it's rated for 65,000 amps. Is that still unsafe to operate that if it's got a level 2 sticker on it?
But the rating isn't for the arc flash rating, so it's not rated to guarantee it's going to contain the arc flash inside the gear.
Okay.
So
inside that enclosure.
Inside, yeah. So the question you have to ask yourself is where are you making and breaking the power, and are you inside or outside that arc flash boundary? So if you're standing right in front of it and it's level 2, then I would imagine you're not outside the arc flash boundary, so you would have to wear the arc flash PPE, unless it's arc rated gear.
Oh,
Motor starter next time.
Oh, so I'm just gonna
No,
upfill
this
that
is
one.
specifically designed as arc rated gear.
Huh.
more available, but still it's not all that common. Installed applications, I guess. It's not the type of clients that I usually end up. So if it's not arc rated, so that'd be the first question. If you're going into a facility, the first question is this arc rated gear? If it's not arc rated gear, then you can't assume that it's going to contain the arc when it happens. And if that's the case, then whatever you're operating, the next question is, where is the contact making or breaking? And am I inside or outside of that arc flash boundary? And if you're outside the boundary, then yeah, you can operate it without the PPE. If you're inside the boundary, you have to have PPE on, even if all the doors are closed and latched.
I see.
But if you're not operating, the other scenario is, okay, well, we've got other work near this. This is the motor starter here, and we're just doing miscellaneous work over here while they're running. If it's energized, do we have to wear arc flash PPE? And the answer is no, as long as nobody's intentionally starting or stopping the gear. If it's remotely operated from a control room somewhere, then the correct protocol would be for somebody to make sure nobody's in front of that gear before they open and close breakers.
I see. That's a common misunderstanding.
So that goes back to the two times when arc flash hazard exists is obviously when there's exposed energized conductors, but also anytime I put it as starting and stopping current flow, because that includes a broad spectrum of switches, breakers, whatever the case may be. If you're starting or stopping current flow, you're interrupting the energy in a way that it could potentially result in an arc flash event. And in that case, you have to do a risk assessment and determine what PPE you need.
So the safe protocol would be going forward, any panel that's arc flash rated concern, above a certain level, always tape off and that area right in front of it to make sure you're typical, like 36, 42 inch, 48 inch rule, same for panels across from each other. Same general idea for any panel that is an arc flash rated concern. Just tape off that area, just so generally operators and non-output rated people should not be basically in front of those panels that are starting and stopping automatically. Because we think of automatically, tons of panels that are powered and automatically controlled remotely from they're going to be starting and stopping regardless of VFDs or cross-line starters all the time.
Right.
So following that thought process, basically every panel that's arc flash rated above 2 and higher should be probably taped off to ensure that whatever that distance is outside of that door.
Yeah, whatever, if it's stickered, whatever the boundary is, if it's not, then you can go by the tables and it's up to you to get that boundary. And one thing that is explicitly talked about is like tripping. If you've got a breaker that's closed, is it hazardous to walk by it because it could trip? And that's excluded from the requirements because the likelihood of somebody walking by it and it tripping and it having a arc flash in that moment is so remote and improbable that it's not included. The intentional operation is where there's an operator in somewhere that is making a conscious decision, I'm going to open this breaker, I'm going to close it. In that case, the expectation is somehow verify that somebody's not in front of that breaker. Now, if you've got a scenario to where you've got a pump that's monitoring pressure and it drops below a certain amount of pressure and it automatically turns on, I can't think off the top of my head anywhere that's specifically addressed. To me, that kind of goes back to the tripping aspect of the probability of you walking by there and it's coming on and it has an arc flash would be so improbable that you wouldn't have to worry about it. But that being said, if there's a scenario where you've got this gear that's automated and it's gonna be coming on and off, and we're gonna be spending 4 hours today in front of it, then to do that 4-hour task, maybe we need to find a window where we can de-energize all those controls, where they're not coming on and off when we're in that area. So that's where the risk assessment really comes in to evaluate, you know, what are we doing? Are we just walking by the gear? That's not a problem. Are we setting up for a week in front of this gear? Well, then maybe we need to take some extra precautions to keep it from automatically operating. That makes sense. That's the challenge, and that's where I sympathize with the folks that are writing the 70E standard, is there's so many variables and so many scenarios to have a solution for all of it is going to be impossible, and that's where they've done a good job of shifting the emphasis to the risk assessment. That we always need to do a risk assessment, evaluate the conditions, and then make the best decision. Because if you're going through that process, thinking it through, and we can't predict the future, but at least we can do the best we can with the information we have.
What standard defines the requirements for ARC rated?
For ARC rated, I believe in the US it's an ANSI standard, and I do it.
You don't know which one?
No, not off the top of my head. I would have to look it up. I think the IEC in Europe, maybe. But
I would think it'd be IC in Europe, yeah.
yeah, off the top of my head, I don't have that. But I do remember that it'll be multiple ones, because there's one that's for medium voltage switchgear, there's one for low voltage, but yeah, it's, but I don't know it off the top of my head.
That's crazy.
It's probably somewhere right there. Give me a few minutes, I can probably find it.
Google.
Yeah, that'll tell you.
Now, the types of scenarios that I discussed, combination motor starter, control panel, push buttons to start a contactor inside there. What is a safe arc flash level to do that operation? It's a category 1. You know, I guess you still got to look at that boundary, right?
Yeah, and you'd have to do the calculations, it all depends on the available fault current in that place of the system.
Yeah.
And, the protected device upstream is gonna drive that. And it could be a wide range of.
Okay. Because you've got like a breaker inside that panel in front of that starter. And most likely that shorter distance you would have to have. Yeah, most of the time you see the sticker on the panel, it's gonna be for what's in front of, on the line side of that breaker. But does it apply to the motor starter inside that panel?
So there's 2 different scenarios there. If you've got the single enclosure, like say just a
You see what I'm talking about? You see a lot of machinery that comes in, it's got that on there.
Yeah, if it's just a panel, then it's gonna be the main breaker, because a fault down here is most likely gonna propagate into a fault on the line side of that main breaker, because it's all one open enclosure. And so in that scenario, you go by the main breaker instant energy level. If it's a multi-lineup, like an MCC, where you've got columns and you've got the main breaker in a separate column and there's barriers in between, then you can separate it out and say, I'm operating this feeder breaker, if you will, and go by that rating. But if you're operating the main, then you go by that rating. In that case, the feeders are typically significantly lower than the main, because they're protected by the main.
Cause you see a whole lot of OEM equipment. And it comes in, it's got a, you know, disconnect enclosure, hot disconnect enclosure. There's a main breaker and there's the starters and stuff in there, and you got plugs on the outside of it. And so, you know, you see a lot of that. And so I guess that you would have to have the sticker that represents the line side of the breaker, but if you got starters inside there on that low side, that's what you're making and breaking when you push that start button. or stop button.
Right.
And so, you would probably need to have two stickers in that case, wouldn't you, or?
Potentially, it'd have to be looked at if the starter is low enough that it's not likely going to propagate into the main, even though it's in one big enclosure, then you can have two separate stickers. But if it turns out to be high enough energy that it has the potential of causing the main to join the fault, then you just go by the main. So you'd have to evaluate it on a case-by-case basis, really, to make that decision.
Cause you know where I work at, you know, we get a lot of pumps in. You know, some pump stand, it's got a 25 horsepower motor in there, some disconnected closure on there, it's got all controls, you walk up, it's push buttons and power lights and everything.
Yeah.
And so these OEMs build these things and they deliver them to us.
Yeah.
And so, I ran into one of those years ago, and that's came in on a fan project, big old large box fan. Luckily, Patrick Weaver came down and made a determination that it was safe to push the button,
Yeah.
because it was, the available arc flash current was pretty low.
Yeah. And that's why it need to be a case-by-case basis.
Yeah. There's potential for hazard, that's interesting.
Yeah. So now, what I see common a lot now is when you get skid packages like that, speccing it to where it's either a remote mounted enclosure like that, or it's a HMI tablet or something that's connected to it that can be operated from away from it rather than standing right in front of the skid to operate them. Because that actually gets you out of the boundary and then it's no longer an issue. Because the challenge for the skid providers is they don't know the system it's gonna be connected to, which
Right.
drives a lot of the arc flash energy. So there's no way they can say we're gonna give you a arc flash safe piece of equipment, because it's gonna have just as much to do with the system it's connected to from available fault current standpoint.
Next question, I don't know if Kabir gets asked to do this, but, I know that I was talking with one integrator, and he said that customers are starting to ask them to do the arc flash calculations. And so, really to do that, and you correct me if I'm wrong here, but does that integrator need access to the entire model? Because just because they say, well, we're gonna feed that with this breaker here, and there's this many amps available with short circuit current, you gotta run this thing 40 feet, 50 feet, or whatever. You figure out with that short circuit current, what the available current is at this point here, what the clearing time of that breaker might be. But if you go in and you add a panel to their system with a bunch of drives and motors in it, you theoretically change the model, correct? So you need to do a whole new assessment of access to their model, which is either an SKM or whatever, you need to do that whole thing, right?
Somebody will. The way I see it happen more often than not is the host would treat it like a utility. And so here's the point that you're gonna connect to with this breaker, and here's our available fault current now for what's there. And so
Right.
the integrator can take that information and do the analysis for all the new stuff that's going.
Right.
And then in turn around and provide that analysis back to the host, which then all this gear now plays into the rest of this.
Right.
And so then it's not so much that this is gonna change more, but there may be some differences that they have to do for particularly if there's a lot of motors.
Right.
Motor contribution.
But would that change that, but would it change the model as much as it would change that available short circuit current that feed, would it change?
It wouldn't change the available short circuit current. It would potentially change some of the incident energy levels in other places of their system. So they would have to update their system.
Okay.
After.
It could affect another panel, unrelated panel, right? Because
Right.
that motor energy could.
Right, yeah.
transverse over to another panel.
So usually I don't see, unless it's just being used as an opportunity to get a full analysis done on the whole system, I usually don't see that request come in to change, to do an evaluation of the whole system. It's, here's your starting point, here's what you consider in your model as the utility, build out the model from there, and then you deliver that model to them, and they've got usually someone on staff that integrates that into the overall system.
Okay. You guys as integrators, Larry and Jeremy, do y'all get asked to do arc flash calculations? How many emails you put in?
Do what?
You wanna answer this?
I mean, projects I've worked on, I've not been asked to do it.
We get asked occasionally, generally speaking, we won't. And the main reason is exactly what he's saying. We don't know necessarily the available wall current without knowing a lot more about where this is gonna go. And usually, most of the time, people can't answer these questions for us.
Right.
So there's really no way for us to do it if we wanted to. The information's not available.
Right.
Yeah. In a lot of cases, yeah, they hear arc flash analysis and we need one, hey, while you're doing this, give us one.
By the way, Brandon, there is no standard for containing an arc fault for a low voltage system.
Really?
They are using loosely the medium voltage standard and applying it to low voltage.
That's right, that's what I remember
Designs that
seeing
are
that.
out there based around that.
Yeah.
Which is interesting to me, because when you made that comment, I could take you to a dozen facilities where the operator control stations within the arc boundary of the motor control center with the doors closed, right?
Yeah.
And the general consensus I've always been told was, if the doors closed, you don't have to worry about it.
That's right.
Which
That's
is
why I asked this question.
partially true, because there's actually no standard to define how much energy do I have to really contain on a low voltage system. But partially not true, because there's people out there now building ECCs where they're claiming arc containment, but they're doing it on the medium voltage ANSI standard. So it's kind of like interesting, you know.
Yeah.
Yeah, you could order a bucket with controls right on the front.
Oh, well, I mean, every bucket I installed until 5 years ago had local controls on it. I mean, I don't know,
Yeah.
I haven't ordered an MCC in 5 years, so I guess I don't know what's being done today, but it's just one of those things where so you said that literally today, I never thought about it. Just doors closed, I'm not worried about it. Right or wrong, I'm not saying I'm right.
No.
I'm just saying, until now, I really didn't think about it.
I know.
And that's what got me wondering, okay, in situations where we do panel design, where somebody's got buttons on the front of it, there's IC starters inside. We do that all the time, still. So what,
So today's your last day is what you're saying?
I can't say that, because I got too many of them out there that are quoted. I mean,
Yeah.
it's something we got to start thinking about. Because it was never an issue.
I guess you usually think about it in terms of the doors closed, I'm not gonna cause, I gotta do something to call
Well,
that.
even if I cause it, the enclosure's gonna contain it. Generally speaking, that's true, right? And what it doesn't is when the available fault current's above the bracing in the motor control center, and that's where you can get yourself in trouble. But it doesn't mean the standard says that that's okay. And, sorry,
No, that's fine, that's good.
you just kind of created all kinds of problems.
Sorry.
That goes back.
I get that a lot.
Honestly, I appreciate it, so, I don't know if you believe that or not.
I get that a lot. Do you realize what you've done to me today?
So typically they would ask Premier, for example, and then oftentimes they would defer to certain, like one of our divisions is specialized in doing that study. And so they would divert, like our biggest customer always points to our division specializing in arc flash study. It's like, that's all they do, breathe, live and breathe it.
Yeah, we don't do our cross studies.
Yeah.
It's not a service offering we provide, but we do design all
Yeah, that's what I advised the person that contacted me, who's an integrator. And I advised him, I said, unless you guys do that all the time, and do it a lot, need to advise your customers that if they want you to do that, you're gonna have to bring in another, somebody else.
Well,
You
there's
know,
no
do
way.
you wanna accept that liability? That's the big question. You know, so that's kind of the reason why I had this presentation, I feel like it generated a lot of conversation.
You just wanna cause problems. Your whole purpose.
Oh, no. No,
Troublemaker.
no.
Totally get it, seriously, get it.
Well, anyway,
Better this way than the alternative.
Yeah.
so,
That's all I'm gonna say about that.
gentlemen, any more questions?
I don't.
Okay, Tom, I really appreciate you coming back.
Yeah.